Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video, we're going to be evaluating an exponential expression. In other words, we're going to raise -1 to the power pi. Is this possible at all? Let's go ahead and find out. So we have -1 at the base and pi in the exponent. But when you raise -1 to different powers, like think about it. If you square -1, you get +1, right? If you raise -1 to an odd power, then you get -1 again, like this, right? But that's only true for integer exponents. What happens if you raise -1 to the power 1/2? Is this meaningful at all? Maybe we can think of this as the square root of -1. And as you know, the square root of -1 is I. So -1 to the power 1/2 is imaginary. Or can it be real? Or what is -1 to the power 1/4? Is there a single answer? Those are good questions, right? So we're going to go ahead and approach this problem in the general sense so that you can take -1 and pretty much raise it to any power you want. In a previous problem, I had raised -1 to the power I. And do you remember, was it a real number or was it an imaginary number? But you can go ahead and check that out, check that video out here. And now let's go ahead and see how we can raise -1 to the power pi. We have a negative integer raised to an irrational power. Obviously, you can also do stuff like -1 to the power √2, -1 to the power √3 minus √2, so on and so forth, right? These are also interesting problems. Let's go ahead and focus on this one now. We have -1, and we're going to raise it to the power pi. To be able to do that, we're going to be using something called polar form. By the way, if you're new to complex numbers, go ahead and check out my lecture videos. I go over basics of complex numbers and ask a lot of questions. That's how you learn. By asking questions, by practicing, by being curious. And if you like number theory, algebra, and trigonometry problems, then I have another channel, Cyber Math, Cyber with an S. Great, so let's see how polar form works. So thanks to Euler, we have a form for complex numbers that can be written using trigonometry. So if you have a complex number, let's say in the coordinate plane right here, and suppose z can be written as a plus bi, right? That's how we write complex numbers in standard form. And of course, there's other forms that we're going to turn this into. But if you go ahead and connect this complex number to the origin, then you get a line segment. The length of that line segment, which is considered the distance from 0, is called the absolute value of this complex number, which is denoted usually by the absolute value of z, but r is also very common. It's also called modulus. There's another thing you need to know. The angle that this vector or segment, whatever you call it, makes with the x-axis or the real axis is called theta, and theta is called the argument of our number z. And of course, from a little bit of trigonometry, we can go ahead and call this a and call this b. And if you look at it very carefully, you're going to realize from the Pythagorean theorem that the absolute value of z is equal to the square root of a squared plus b squared. Tangent theta is b over a, so on and so forth. There's a lot of trigonometric explanations. But here's the critical part. You can take a complex number and write it as r times e to the power I theta, where r is the absolute value or the modulus, and theta is the argument we just talked about. Okay? So we're going to be doing it for -1. And as you know, -1 on the coordinate plane or the argon plane appears here on the real axis, but in the negative section. And its distance from 0 is 1 unit because it's the absolute value of -1. And the angle it makes with the x-axis is pi radians. Of course, you're allowed to add multiples of 2 pi to it, so you can also call it -pi, you can call it 3 pi, so on and so forth. In the general form, or maybe in the principal form, it can be written as e to the power, because its modulus is 1, e to the power I times pi. But again, you can add multiples of 2 pi to it, and when you do, it's going to look a little different. But let's go ahead and use this for now. So I'm going to go ahead and substitute this. And remember, our job was to find -1 to the power pi, right? So let's go ahead and do this. Negative 1 to the power pi is just going to be e to the power I pi to the power pi. And then that's going to give us e to the power I pi squared. Whatever pi is, you just square it. 3.14 squared, you're going to get, who knows, 9 something, probably, right? It's probably less than 10, isn't it? Yeah, I think so, because square root of 10 is definitely greater than pi, right? I think so. Anyways, so that should be the answer, but what does this mean? So let's go ahead and talk about the polar form of a complex number, or the trigonometric form, and Euler's most beautiful formula. Okay, so here's how the formula goes. E to the power I theta equals cosine theta plus I sine theta. So basically, remember I told you that any complex number can be written as r times e to the I theta. In this case, r is 1, but in general, we should write it. And if you multiply both sides by r here, you're going to get r cosine theta plus I sine theta. And that would be equivalent to a plus bi, right? But in this case, we can safely say that, okay, this is my a and this is my b, because the absolute value is 1. But what does this tell you? This tells you how to write e to the power I pi squared. How do you write it? You basically write it as cosine of theta, which is pi squared, plus I times sine of pi squared. If you want to use parentheses, be my guest. I generally don't use it, but sometimes it'll help avoid confusion, so I'm going to use it in this case. But that's basically what the answer is going to be. But what is that supposed to mean? Well, this is a complex number. You go ahead and evaluate pi squared. So if pi is equal to 3.14, you're going to multiply it by itself. I don't have an answer, but you can do it with a calculator. And then once you find that, you're going to find the cosine of that angle. But you've got to be careful. It's supposed to be in radians. So whatever you get, you kind of have to take out multiples of 2 pi or whatever. Just plug it into a calculator. When you do, it should give you the value of cosine pi squared as well as sine of pi squared. Make sense? So if this is your a and that's your b, then you can just write it as a plus bi. But it's okay to leave it like this, because this is the most compact form for this complex number. All right, so that's pretty much how you do it. Now let's go ahead and quickly talk about what happens if you use a more general form like e to the power I times pi plus 2 pi n. If you use this to replace negative 1 with, and when you raise both sides to the power pi, of course you're going to have another pi here. That's going to give you e to the power I pi squared plus, and then you're just going to multiply this by I pi, 2 pi, and I pi. Of course, there's going to be another pi squared here. Make sense? So it's pretty much the same thing. And let me tell you something interesting. This is actually, these are equivalent, because when you multiply or separate it like this, what's going to happen is this is going to be 1 all the time. So when you raise 1 to the power pi, it's also going to be 1. So you're going to pretty much get the same result. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out Cyber Math and A plus BI, and bye-bye.